let's do some more formal definition of the derivative practice. Derivative. Remember, the derivative of a function is this guy. It's also the slope of the tangent line. So, in order to find the derivative, we're really just using the limit techniques that we already learned. Now, remember, every time we try to take a derivative, we're going to get an indeterminate form 0 over 0. Now, there are three ways to handle that, right? We need to factor, we need to multiply by the conjugate, or we need a common denominator. Let's take a look at example 1. Here we're finding f prime of 7, which is the limit as h approaches 0 of f of 7 plus h minus f of 7 all over h. And you don't need to write this first step. You can just dive right into plugging it into the function, right? We get 4 over 7 plus h minus 4 over 7 all over h. Okay? Now, when we have fractions, you see we have what's called a repeated fraction. It's kind of nasty. So what we can do to make life a bit easier is we can write the limit as h approaches 0 of 1 over h times. And now we can just write this stuff out. See how much nicer that looks? I mean, it doesn't look nice, but I think it looks a little better. Now, if we want to add these fractions, leave a little bit of space here. We need a common denominator. So we're going to multiply this guy by 7 over 7 and multiply this guy by 7 plus h. 7 plus h over 7 plus h. And now we can talk about the limit as h approaches 0 of 1 over h times, and then this is going to be 4 times 7. Oh, sorry, I wrote a plus here. That should have been a minus. Sorry about that. Minus 4 times 7 plus h all over the common denominator, 7 plus h times 7. And when we do this out, we're going to get the limit as h approaches 0. 1 over h times, and note that we're going to get 28 minus 28 minus 4h, right? Note that we get negative 4h on the top, and we still get 7 plus h times 7 on the bottom. And at this point, we just cancel the h's, right? Because we had an h in the numerator, h in the denominator. And now we can take the limit. And so we're going to get negative 4 over 49. Okay. Let's look at this example, right? This one involves a square root, right? We had the fraction. We had to use a common denominator. Here, what do you think we're going to do? We're going to multiply by the conjugate, right? Find the equation of the tangent line to that curve at 6, 9. Now, one thing, that's actually not quite right. It should be 6, 3. Not on that one. Anyway, we're looking for g prime of 6, right? We're plugging in g prime of 6. And so we're going to get the limit as h approaches 0 of g of 6 plus h minus g of 6 all over h. Now, let's clean this up a little bit before we simplify. This is going to be root 9 plus h minus root 9, which is just 3. Right, just simplify it a little bit. Now, what do we do in this situation? We have a square root. We know it's 0 over 0. That's right. We multiply by the conjugate. Right? Now remember, top gets cleaned up, the bottom looks even messier, but we do not simplify, right? So we're going to get on the top 9 plus h minus 9. Bottom is just h times all this junk. And sure enough, these 9's cancel. We're left with limit as h approaches 0 of h all over h, root 9 plus h plus 3. And then these cancel out. We replace that with a 1. And then we plug in and we get our answer, right? 1/6. Now note that it asked us for the equation of the tangent line, right? Not just the slope. So we're going to say tangent line has slope 1/6, right? Which equals f prime of 6. And point, this was actually given to us at the beginning, 6, 3. So the tangent line has equation y minus 3 equals 1/6 times x minus 6, right? Where am I getting this from? Y minus, well, let me use a different color. Y minus 3, what? Equals the slope times x minus 6. Okay. So that's our answer. This one, a little bit tricky. Gonna let you try that one. This is pretty tricky though. Just a lot of simplification going on. And let's finish with example 4. Okay. Now here, what we've done before is I've said, okay, I'm going to give you a function. I'm going to give you a point. Find the derivative of the function at the point. Write the expression for the derivative, and then simplify it. Here it's the opposite. Here I've given you the expression for the derivative of a function at a point. And I want you to tell me what that function and point are. So for part A, you might notice that it looks like whatever we're doing, we're raising something to the 10th. So you might figure that f of x equals x to the 10th. And well, what's the x value in question? It's 2. So there you go. How about part B? A little bit tricky right here, but if you notice that, well, what happens if a equals 16? Well, I guess 2 really is the 4th root of 16 if you think about it. And so f of x is the 4th root of x. And last but not least, this is kind of a tricky one right here, but here I think it's pretty clear that a is going to equal 5, right? We're using that older definition of the derivative. And it may not be obvious, but if you plug 5 in to 4x squared minus 3x, you do get 85. So this is the f of 5 right here, and this is f of x. Okay. So that's what we've got.